Hey there, science enthusiasts. Today we're diving into the fascinating world of biogenic amines and their incredible role in our bodies. Think of them as tiny chemical messengers with big impacts. We explore how these nitrogenous compounds influence everything from mood to development. First up, what exactly are biogenic monoamines? Well, they're a special class of small nitrogen-rich molecules like serotonin, dopamine, norepinephrine, and histamine. These trace amines the body's little messengers are derived from amino acids through processes like decarboxylation and transamination. For instance, tryptamine comes from tryptophan, tyramine from tyrosine, and octopamine from its namesake amino acid. Molecules aren't just for show, they play vital roles in regulating biological processes such as gastrointestinal motility, neuronal plasticity, and even behavior. How are these monoamines synthesized? It all starts with amino acids, the building blocks of proteins. Enzymes called decarboxylases remove carboxyl groups, producing amines like dopamine and serotonin. Transaminases transfer amino groups between molecules, further refining these compounds. Histamine produced via decarboxylation of histidine, and their production is tightly controlled in their body. Once synthesized, these biogenic amines act on specific receptors, monoaminergic receptors, to modulate various functions. Serotonin acts on receptors in the dorsal raphe nucleus, influencing mood, sleep, and even neuronal plasticity. Dopamine, originating in regions like the ventral tegmental area, is crucial for reward and motivation. Histamine, produced in the tuberomammillary nucleus, helps regulate wakefulness and arousal. They're not just floating about freely. These molecules can also modify proteins through a process called monoaminylation, a type of post-translational modification. Histones are proteins around which DNA is wrapped, getting a little chemical makeover. Histone monoaminylation involves transglutaminase enzymes attaching monoamines like serotonin and dopamine to specific glutamine residues on histones, such as histone H3. This modification can influence gene transcription, affecting neuronal plasticity and behavior. Transglutaminase is like the body's molecular glue, catalyzing reactions such as aminolysis, hydrolysis, and alkylysis. It forms a diester intermediate with glutamine residues on target proteins like histones, and then transfer amines to these sites. This process can alter chromatin structure and gene expression, impacting processes from embryonic development and cell differentiation to morphogenesis and axis pattern. So next time you think about mood swings, stress, or even how your body adapts to new experiences, remember the tiny but mighty biogenic monoamines and their enzymatic partners, transglutaminase, methyltransferase, and more, working behind the scenes to keep everything running smoothly. Science is truly amazing, and these chemical messengers are proof that even the smallest molecules can have the biggest impact. Stay curious.